Okay, welcome back. I'm going to cover cosine law here today. I'm just going to start with the formula, go through solving problems. As far as the development of the formula goes, I can post that later on if we want to. So essentially there are two situations under which the cosine law will be used. The first thing to recognize is if we haven't got a right angle triangle, then we'll consider looking to see if the cosine law will apply. As long as we have our right angle triangles, we'll stick with the old sine, cos, and tan, deal with the primary trig ratios. So in both examples that are up here, you can see I don't have a right angle triangle, or at least I don't have one for sure. I don't know that I have one. There's no angle indicating or indicated as being right angle. So my two situations, these are two kind of special cases. The first one, the one on the left here, occurs when I have exactly this pattern. I have a side, well, let's say I have two sides and the angle in between them, the angle that joins them together. Okay, so it's what we refer to as side angle side. But again, we got to stress that it is two sides and the angle that's holding them together, not any two sides and another angle. It's a side touching an angle, touching the other side. I have those three pieces of information specifically. Now, if I do, I'll be using the cosine law, and what I will be finding is that third remaining side, regardless of what the question actually asks. The question may say, find this missing angle over here. If it does, fine, we'll get there eventually. But for now, I'm always going to be looking for the third side if I have a side angle side information. The formula then, again, basically this is just my starting point. And as much as it's long and messy, first of all, I guess you sort of notice that part of it looks pretty familiar. This is the Pythagorean theorem. And if actually you tried the cosine law using a 90-degree angle, you would find that cos of 90 is 0, and so this whole section becomes 0. And it turns out then that the Pythagorean theorem is just a cosine law dealing with a 90-degree triangle, or at least the 90-degree angle part of the triangle. So solving this should be pretty straightforward. I have the two sides that I'm given will be the two sides here and here. The angle that I'm given will be going in here. And you want to recognize, in case you have forgotten, when we use this, when we use angles and sides named A's, B's, and so on, we always line it up such that the angle is across from the side, or then the angle is across from the side that has the same name. Sorry. So in this case, I'm searching for side small c, and I'm considering this side or angle capital C. Now plugging in the numbers again should be fairly straightforward. I'm calling A my 42 and B my 80, but certainly going the other way would be the same thing. They're just the other two sides. Pick one for A, pick one for B, and continue on. And now you'll notice that everything is on the one side of the expression, and the one side of the equation. I can pretty quickly and easily punch this into a calculator. And when I do, depending on the calculator you have, you'll either just, if it's a newer calculator, you can punch it in exactly as written. Don't forget your brackets or your multiplications in between these various parts over here. So if I'm going through this, I press 42 squared plus 80 squared minus 2 times 42 times 80 times cosine of 75 equals the whole thing at the end. Okay, when I do that, I get c squared being approximately 6,424.736. Now, leave that on your calculator. Don't hit equal, or sorry, don't erase what's on your calculator. And essentially, to find c, I'm going to take the square root of whatever my previous number was. Now again, you hopefully on your calculator you still have whatever other decimals were there. And the calculator will actually remember the rest of the number, that the non-printed part of the number as well. When we take the square root of that, we get approximately 80.15. Okay. So that would be the missing side over here with the x. And then, of course, if we did have something more that we were trying to do with the question, we could continue using that value throughout the question. At this point, that's all we wanted to see, though. Now I'm going to go through the second example. I'll do it on a new page, though. Okay. So I'm just going to remove case 1 here to have a little bit more room. Okay, so now in the second case, we see a little bit different information given to us. We have specifically in this case the 3 different sides, no angles. So that is the second case that I'm interested in. When I'm, similarly to what we said before, here the C, what I have labeled as C, and what I've labeled as capital C over here, are any pair of side and angle that are across from one another. So in this case, if I'm looking for this angle down here, theta, I'm going to consider this capital C and consider this small c. And I will line them up in that way so that when I do put the values in, my small c goes, or sorry, my 63 goes in for the small c, and the angle I'm looking for is the one over here that is across from it. Before I do that, though, you can see that this time all the information I want to be together is not actually together to start. So I'm going to start by rearranging the equation. C squared over here, I want to isolate cosine of c. And so I've got c squared. I will subtract the a squared from both sides, subtract the b squared from both sides, and I have negative ab times cos of c left over. Then I'm going to divide through by the negative 2ab, divide both sides by negative 2ab, and we get and so this is the same equation that we started with, but again, it's rearranged. You may also see it written down just slightly differently, where basically the negative sign's been divided through the rest of the question, and you see a squared plus b squared minus c squared over 2ab. And if you recognize, essentially if I either multiply top and bottom by the negative 1, or think about it in terms of dividing the negative 1 into the top part, this is what we end up with here. Now, which exact form you start with does not matter to me. I will tend to use this because I'm simply going to be rearranging the original formula whenever I need to use it. But again, all 3 forms of the equation, this, and this, are identical, and any one of them can be used at any time. So all of that said, I'm looking to solve the problem given on the left here. As we said, if I'm looking for the angle C here, 63 is my small c, and so I will just go with this one here. Maybe I'll rewrite it so it's cos c on one side So again, that's the form that I will tend to use. And I'm going to go ahead and solve this and then talk through in just a moment. Okay, so finishing up here. Um, this is an optional move, but it may be one that some of you have to do. What I've done here is basically worked out the numerator, worked out the denominator in my cosine line where I'd left things. Well, just basically 63 squared minus 80 squared minus 42 squared is negative 4195. The denominator works out to negative 6720. Certainly, you don't have to do that, but if you need to, that's what you should be getting at that point. As we move forward then, if you can do the entire calculation from the right side in one, you end up with a decimal, hopefully that looks like this one. And to solve that, we have to, if we're looking to find the angle, we use the inverse. And again, the inverse is on your calculator means using the shift key, the second function key, or the inverse key, usually a different colored key that is on the upper left corner of the calculator. So to find the angle, use the inverse. Drill that into your head. To find the angle, use the inverse. To find the angle, use the inverse. To find the angle, use the inverse. Okay, whatever you have to do, get it in there. So I'm doing inverse cos of that number, and I get a value around 51.3. So just sort of quickly, if you do want to go kind of straight from here to at least to that point, you want to recognize that essentially your numerator and your denominator are bracketed expressions. So the easiest thing is probably to go ahead and punch in your left bracket, 63 squared minus 80 squared minus 42 squared, close your bracket, divided by, and then again in brackets, negative 2 times 80 times 42. If you know a little bit better how to use your calculator, there is you have another option there of just going 63 squared plus 8 or minus 80 squared minus 42 squared equals. When you hit equals, it essentially calculates the top part, and then dividing by each of the bottom, or each part from the denominator, divided by negative 2, divided by 80, divided by 42. Those are essentially your options if you don't want to write it out. Certainly doing this is fine. It's not needed, but it will get you there. And if you're finding you ever have trouble getting the right answers, I'd say always use that red part as your fallback. Work out the top part, the numerator, work out the bottom part, the denominator, and finish up the question. Okay, so those are the two types of questions for which cosine law will be used. We have exactly three sides. We're going to use a version of the formula. It can be the original for sure if you want to just go back to using the actual formula and rearranging once the numbers are put in, that is fine. It can be a rearranged version of the formula in this form as well. And of course the other case was specifically two sides and the angle that binds them. So side, angle, side in order, the two sides that are touching at a corner and knowing that angle that's in between them. Okay, thank you very much and good luck.